Let's go through the code 1723. Find the minimal time to finish all jobs. And for this question, it gives us an integer array jobs. And the every job I is the amount of time it takes to complete the I job. There are k workers you can assign the job to. Each job should be assigned to exactly one worker. The working time of our worker is the sum of the time it takes to complete all jobs assigned to it. Your goal is to devise an optimal assignment such as the maximal working time of any worker is minimal. So that is we try to assign those jobs to the k workers, and we try to get for every worker it has a working time. We find the maximal of all the workers' working time. And we should minimize this maximal value. So for this question, there are multiple ways. Today, we are going to go through the bit mask. On LeetCode, there is another question posed earlier. I will go through DFS way, which is similar to this in a later session. So let's recover the bit array knowledge. So we know, let's review this part, right? So we know the first thing we want to review is that 1 and 1 equals 1, right? And 1 and 0 equals 0, and 0 and 0 equals 0, and 1 or 1 equals 1, and 1 or 0 equals 1, right? And 0 or 0 equals 0. And another is 1 XOR 1 equals 0. And 1 XOR 0 equals 1. And 0 XOR 0 equals 0, right? This is the first character. Second one is that we want to say, for example, if we want to check the jth, whether the jth digit from the right is 1 or not. For example, check jth bits is 1. Jth, that is from right, is 1 or not. What we are going to do is that we are going to check that whether A and 1 shift J if it done equals 0, that means the jth bits from the right is 1. Third part is union of A, B, right? So that is A or B. The fourth thing is that the intersection of AB is A and B. Okay. So union, for example, A is 1, 0, 0, 1, right? B is 0, 0, 0, 1, 1. So A union B will be that A or B, that will be 1, 0, 0, 1, 1. Okay. And if A is this, right? So A and B will be 0. This is intersection, right? Intersection is N, union is O. The fifth question is if The fifth feature is the check if B is a subset of A. What we are going to do is we try to see whether there are intersection, do A and B equals B, right? Whether they are intersection. So if that is the case, that means B is a subset. The sixth feature we want to is that if B is a subset of A, remove B from A. That is A XOR B. The seventh question, feature we want to say the largest subset of A. That is remove the rightmost one bit. So that is A and A minus 1, right? The eighth feature and using the seventh feature, for example, how can we calculate how many digits in a number? We can say for int I equals A, right? I done equal to 0. I and equal to I minus 1, right? So in this case, we can have count plus plus, right? In this case, we can count how many bits of a number. And the eighth feature is that how can we enumerate all subset of A, right? So let's say in this case, what we'll do is that for int I equals A, I doesn't equal to 0, I and equal to I equal to I minus 1 and A, right? So this is the way enumerate all of the subset of A. For example, A is 1, 0, 1, 1, right? So in this case, I minus 1 is 1, 0, 1, 0, right? So this one and this, right? So we get the first subset. This is I. This is I minus 1, right? So we'll say 8, right? So this one and this, so the I become 1, 0, 1, 0, right? So this is I, and then in the next round, right? So it will become 1, 0, 0, 0, 1, right? So A and I minus 1 will become 1, 0, 0, 1, right? In the next one, it will become 0, 1, 0, 0, and in the we can have another line, right? 1, 0, 0, 1, 1, and then in this case, it will be 1, 0, 0, 0, 0. and when this one minus one, right? So will be 0, 1, 1, 1, 1. And then the A and I minus one will be 0, 0, 0, 1, 1, right? And if this one minus one, there will be 0, 0, 1, 0, well, 1, 1, 1, 0. Okay, so this will be 0, 0, 0, 1, 0, right? And when this minus one will be 1, 0, 1, 1, 0, 1, and we end. This will be this, right? So doing like this way, we can iterate all of the subset of A. So this is we are trying to review the feature of bit mask. So for this question, then we can write use bit mask to write this question, and we are going to use two-dimensional array called dp equals new int. So there are k workers, right? So there are k workers. So we need to assign to k workers. And for the job, that may have different states. That may have one shift. Let's have int n equals job spot length. So there are these kind of states, right? And what we want to return is return dp k minus 1 and 1 shift n minus 1, right? So this means so dpi state. This means when we iterate I index I worker, right? That means index I worker for this state, the minimal time. Okay. So we say dp0, that is first worker, right? We can try to see trying to have the initial value for all of the state. So the state, this will be our initial value. We want to have for the first worker, we trying to see how many time it will use. So so what we do is that for int we know dp 0, 0, right, equals 0. This means for the first worker, if we don't assign any job to him, the time to use is 0, right? So for example, I have dp 0 equal have binary 2, this is 2 base, right? Base 2, whatever. For example, we have 1, 0, 1, 1, this kind of state. That means I assign this job, this job, this job, and this job to work one, right? To work zero, the first worker. So we are going to say for state equals one, right? State smaller than one shift A, right? State plus plus. So we have this kind of feature trying to check the J's from the right base is zero or not, right? So we'll say if so this is the integer so on this state so there are n jobs, right? So so the length it's if of course we can try to check 32, right? Actually we just need to check for length n, right? So what we're going to do is that for int j equals 0, j smaller than n, j plus plus. So if from the right, the j's digit is 1, right? So we'll say if state and use m, right? 1 shift j. And equal to 0, right? That means from the right, the rightmost, the j space is 1. There is a job, right? Then we can use this kind of feature that because 1 is a subset, the 1 shift j is subset of state, right? So remove this subset from A, right? From this state that is use XOR. So we know remove 1, right? So we'll say dp state XOR 1 shift j. So we'll say dp state dp first worker state equals dp first remove this job, right? And also we'll add this jobs j, right? This kind of time. So this is the first for the first worker, right? And he finished this kind of state of job workers jobs. The minimum time will be this kind of time, state. This plus this job j's time, right? So this is very intuitive. For example, I assign this kind of jobs to worker 1, right? So that means the first worker he need to take the job 0, job 2, 3, 4, right? So the total time will be all of job 0, 2, 3, 4 added together, right? So this is the initial value. Then what we need to do is that we need to follow right for int worker equals 1, worker smaller than k, worker plus plus. And we want to see the state. So we also iterate those kind of state, right? For state equals 0, state smaller than 1 shift A, and then state plus plus. So we know BP worker. That means for this number of workers, it already worker not we call worker index will be better, right? Number of workers already assigned jobs in the state. So equals BP worker minus 1, and we need to enumerate all of the substate of this state, right? Or substate plus we need to have minimum, right? Minimum mass min, and also BP 0 is substate, right? So how can we iterate the substate of a state? That is, we have this, right? For int substate equals state substate equal to 0, right? Substate equals state and substate minus 1, right? In this case, we'll have DP worker equals worker state equals maximum DP worker minus 1 substate and DP 0 substate. This will be state XOR substate, right? We can also put this state XOR substate here and put a substate here, right? That is the same thing. So in the end, we just return dpk minus 1 and 1 shift A minus 1. Right? That means all of the jobs being assigned. State 1 shift 0. So this is dp a minus 1. The things that we are get a minimum, right? So we need to set an initial value to be maximum value. Okay, so we have parameters final static int I enough equals integer next value. Let's fill the result, right? For dp arrays fill the final. Okay. So issues. So 8 0 0 if job man so for this worker data substate iterate all of the substate dp this is not correct, right? This will be max, and what we're going to do is actually max.min on this, right? Max of max. Okay, so this is a bit mask and a DP way to do these questions.